Here's sample test 3, problem number 3. In the circuit at left, what is the magnitude and sense, the direction of the current in the 20 ohm resistor shown? Alright, we wish to use the techniques of our circuit analysis. We start by marking our batteries, positive and negative for the long and short bar of each battery. And then we're going to assume current directions. We're going to use our battery orientation to help us with that. We want to come out with currents coming out of the positive end of our batteries. So our I1 is going to be going around like this, and our I3 is going to be going around like this, coming out of the positive end of the batteries. Now at this junction up top, we've got I1 and I3 flowing into that junction. In order to have current conservation, charge conservation through that junction, we need a current coming out. So our I2 will be coming out. We don't have to do this way. We could have all three going into the junction, and then all our currents would add up to 0, and one of those currents would have to be negative. That'd be fine, but let's do it more intuitive way. So based on this, we have I1 plus I3 is equal to I2. The current flowing into that junction equals the current flowing out of that junction. Based on these current definitions, we can mark our resistors. Where the current flows into the resistor, that's the positive end. Where it flows out, that's the negative end. Same thing for I2 here, from top to bottom. And I3 is going left to right through this 10 ohm resistor down below. So there's our positive, negative there. Very important to get these positive and negatives right. Since we're interested in the current I2, the current through the 20 ohm resistor, we want to focus on the loops that have the 20 ohm resistor in them. And that will be the left loop here and the right loop here. So those will be the two loops that we do because we want the current I2 in both of our equations. If we do the left loop, we can start anywhere on that loop, go all the way around to the starting point, either clockwise or counterclockwise, it doesn't matter. So let's start at point A and go clockwise around this left loop. We first walk into the negative end of the 10 volts. Wherever we go into the negative end, we're going to subtract that voltage. Wherever we go into the positive end, we're going to add it. So we have a negative 10 volts. Then we go into the positive end of that 10 ohm resistor, so that's going to be plus 10 I1. And the positive end of the 20 ohm resistor as we come down will be plus 20 I2. We finally make it back to point A, so our total voltage as we traverse that loop will be 0. We want I1 in terms of I2, so now we have 10 I1 is equal to 10 minus 20 I2. Divide both sides by 10, so we have I1 is equal to 1 minus 2 I2. Nice. Okay, what about the right loop? If I look at the right loop, I have, let's start at point B here and just go around clockwise. We have a plus 15 minus 10 I3, and then we're going in the minus sign of that 20 ohm resistor, so it'll be minus 20 I2, and then nothing else, so that would be equal to 0 once we get back to point B. We want I3 in terms of I2, so we have 10 I3 is equal to 15 minus 20 I2, or I3 is equal to 1.5 minus 2 I2. Nice. Alright, so let's put this all into this I1 plus I3 equals I2. So we have I1, which is 1 minus 2 I2, plus I3, which is 1.5 minus 2 I2, and all that should equal I2. Solve this for I2, put the two I2s on the other side, so I have 2.5 is equal to 5 I2, or I2 is equal to 2.5 divided by 5, which is 0.5 amps. So that is the current in the 20 ohm resistor, 0.5 amps. So that is part A. Sounds good. Just for reference sake, I1 would be equal to 1 minus 2 I2, 1 minus 1, which is actually 0. So there is no I1 current. Goofy. I3 is equal to 1.5 minus 2 I2, which would be 0.5. So I1 and I2 and I3 are the same, 0.5 amps, as they're going around that loop there. Just kind of nice to know. What's the potential difference VA minus VB? To find VA minus VB, we're going to just walk our way from A to B, adding our voltages along the way, any way we wish. So the easiest way would be to walk along this path from A to B like that. And if we did that, then VA minus VB would be equal to negative 20 I2. That would be it. So that would be a negative 20 times 0.5, which would be a negative 10 volts. So that is VA minus VB. That's part B of this problem. Just for a check, we could try a different way. Let's try walking this way. Let's go this way with the blue. And if we did that, then we would say VA minus VB is equal to negative 10 plus 10 I1 would do it. And that's equal to negative 10 plus 10 times 0, which is a negative 10 volts. Doesn't matter how you walk from A to B in this case, you should always get the same change in potential. That's the neat thing. Even if you had a negative current, you would plug that negative current in and get the right potential. So you can't go wrong if you stick to your guns and stick to your results based on your assumptions. So that's our answers for A and B on this question.